To understand how Wireshark displays the protocols, it's important to have an understanding of a layered network model, such as the OSI, the Open System Interconnection model. So we want to talk about that in this module. Wireshark is capable of dissecting hundreds of different protocols. For example, AppleTalk, both wired and wireless LANs like Ethernet, Wi-Fi, Token Ring, mobile telephony networks like GSM, UMTS, and the more recent LTE standards. The sensor IoT networks such as Zigbee, Wireless HART, and Bluetooth Low Energy. SIGTRAN, which is used in some of the telephony networks to send PSTN signaling over an IP network. And of course the TCP/IP suite of protocols, which are so widely used in our enterprise deployments today, as well as our home networks. And that would cover, of course, IP, TCP, UDP, HTTP, ICMP, etc. How does Wireshark display so many different protocols in a consistent way? Well, the answer to that is that Wireshark uses a layered approach to display each of the different protocols. And what I mean by that is that it displays packets at the layer 2 and everything contained within that packet all the way up to a layer 7. And in the packet detailed pane, level 2 is exposed first, then level 3, etc. So let's take a quick look at Wireshark just to make sure we're clear. And you should do this with the packet capture that you just created. In my packet capture, my first packet is a TLS packet. And you can see it's carrying application data. I'm actually watching a Netflix movie, and Netflix encrypt their packets. And so here you can see a secure socket layer. So this is my highest layer that I'm able to see. I can't actually see the actual application data because you can see it's actually encrypted. And without the decryption key, I'm not able to decrypt that data and display it. SSL sits on top of TCP, and so you can see my TCP protocol, which is my layer 4. And then that sits on top of IP version 4 in this example, which is my layer 3 protocol, and then that sits on top of Ethernet, which is my layer 2. Now you may be thinking to yourself, well, what is this one called frame? Is that anything to do with the physical layer? It's really important that you understand that Wireshark does not expose the physical layer. So even though most physical layer protocols do add a header, that is not exposed with Wireshark. Now there is an exception, and that is with Wi-Fi networks. We'll talk about that later when we talk about Wi-Fi networks. When you think about a layered network architecture, the application data at the highest layer is then encapsulated as is passed down the protocol stack. In my example, my Netflix video was broken into packets, and each packet was encapsulated with an SSL protocol that defined a secure channel between two network nodes. After the SSL header was added, it was then passed down where a TCP header was added. TCP established a connection between the two network nodes and ensured that the packets would be delivered to the endpoint in the same order in which they were sent. This then is passed down to the IP layer in my illustration, which adds the IP header, which includes the IP address, which is then used for routing that packet across the IP network, making sure it gets to the desired location. That is then passed down to the data link layer 2, and the data link protocol adds a header which is responsible for making sure that that packet gets to the next node in the network. So it deals with the single link between two network nodes. The packet is then passed down to the physical layer, and a physical layer header is normally added before it goes down the wire. Wireshark does not expose the physical layer header, but it does expose the layer 2 protocol and above. If you understand the layered approach approach of networking, then you'll understand how Wireshark displays the content of a packet that's going over your network. One last thing I want to mention before we finish up is that in the packet list window, the protocol column displays the highest layer protocol that Wireshark is able to interpret.